Alright, welcome back to the shop. So today we got kind of a interesting, more unique video. What we're going to do is we're going to check out a three-phase, what they call star wound motor, what it looks like, its windings and whatnot. We're going to check one out, first with resistance and then with a Megger. A precursor to this type of meter, mega ohm meter, is very dangerous if you do not know what you're doing. The insulation tester it puts a high voltage out, up to 1,000 volts in this particular model. So you gotta know what you're doing, or you shouldn't be touching it. It's not something to play around with. We're just screwing around in the shop here. We got the tools. We're gonna test out this motor here, and we're gonna see how it works, and maybe help some guys out. Okay, so first thing we're gonna do here is we're gonna test the meter in both functions. We're gonna test it here in the resistance function, open leads, and then we're gonna clamp it together, and we can see that we have 0K ohm. So that's working. And then what we'll do is we'll come over here, and I think we'll test this. It's a 480 volt motor. Yeah, you should probably test it at 1,000 volts, but we'll go 500. What the heck? So first test here with the mega ohm meter. Again, you got to be super careful with this. Do not touch those leads. So we hold them separate, and we test it, and we can see that that's its maximum reading, 4 meg. So that's good. That's open. And then what we'll do is that tells you how much voltage is in the circuit. There's none. Now we clamp these together. There we go. And we'll test it again. And you can see that that's a very, very low resistance because it's shorted. So that's the first step. We test the meter. So first off, what we're going to do is we're going to put this in resistance. We have the leads here, alligator clamps, and we're going to start reading some resistance here, and then we'll make notes what we meter here. So what we'll do is we'll test from 7 to 8, from 7 to 9, and to 9 to 8, and we should have the same resistance. And then we'll test from 1 to 4, 2 to 5, and 3 to 6, and these should be the same resistance, and we should see something interesting in the numbers when we do those. So here we go. We'll get started. Okay, so this is 9, and this is 8. You'll notice I have wire nuts on all the ones that I'm not metering. So here we go in the meter. We have 10K. So 9 to 8, we have 10K. And we'll let 9 on. And 9 to 7, we have 10K. So we'll make note of that over here. We'll let that on. And we'll go 7 to 9. Or I'm sorry, that's 7 to 8. And that's 10K. Okay, so we can put the wire nuts back on these guys. So now what we want to do is we'll look for that 1 to 4. Got to find the leads. Well, here's 3. Let's see if I can find 6. There we go. So here's 3 and 6, we'll do those two. There's 3. There's 6. So 3 and 6 is 5K. Cap these off again. Okay. Two and 1 and 4 go together. So 1 and 4. Actually, get it on the conductor would help. 1 and 4 is 5K. And 2 and 5. This should be 5. It is. And 2 and 5 is 5K. So what does that tell us? If you're noticing a pattern here, you can see 3 and 6, 5. These are all 5K out here. And the center, because these are tapped, you're reading across 2 coils when you do this, and you have 10K. So 5 and 5 is 10. So your resistances add in series. You're essentially putting 2 coils in series here. Thus you're measuring the 10K, whereas this is just a coil. So you're reading the 5. Okay, so now we got that. What we want to do is double check some stuff here. We want to make sure that we don't have anything from 2 here, from 2 to 8 or any of these. We want to check a few more spots here just to make sure nothing is shorted. We also want to check the ground, which I will do right now. You can see we're open. And we're going to find 8 here. There we go. And all these should be open, and they are. So 2 to 8 is open. We should also be able to go from 8 to ground. Open. Pretty much any of these to ground should be open. So checking motors is just time consuming. You got to go through the whole thing and just keep testing everything until you get there. So I'll probably fast forward some of this as I go through it all. But you get the idea. We're just systematically going through and checking it. Okay, so now we got that part of this done. Now what we want to do is we want to check the insulation value in the motor. And this motor is a 480 volt on the high side of the motor. So we can either do a 500 volt test, or some schools of thought you could do the 1000 volt, but just for playing around here to experiment with the new meter here, we'll just do the 500 volt. So what we're going to start with is we're going to clamp this to ground. And when you do this, you got to make sure that you do not have any connections anywhere other than what you are doing. You see I have all these safed off. They cannot get into anything. Everything's separated. You do not want to have yourself get between this. Don't want to touch any of this stuff. Don't play around with it. So here we go. We'll do a little test. Alright, continuing on, we're just going to keep testing this motor. We did 9 to the ground. Good resistance or insulation there. You're going to want to do the same thing on 7. So that's good. Always make sure that goes to 0 before you disconnect anything. Okay, so that's the inside of this tested. From here to ground, from here to ground, from here to ground. Insulation's all good. Now we want to test from any of these to ground, just to make sure that our insulation's good. Okay, so I'm noticing that if you just quickly push this button on this, you can see I didn't test it properly. You got to hold the button in a little while, and then you can see the voltage bleed off. So don't be in a rush. Make sure you get it in there the right way. Okay, there we go. So we got that from all the other connection points here. We got them all to ground. Everything, the insulation is great. So let's see here if we do, which one is this? This is 1. So if we test from 1 to 7, we should have good insulation. And that is open. Keep in mind, when we connect this to low voltage, we will actually be fastening 1 to 7. So what we'll do is we connect this to here, whereas if we were in high voltage setup or 480, we would connect 4 to 7. And what that does is gives you more coil to go through. So by moving this 1 and putting it on the 7, we actually tie 4, 5, and 6 together. What we'll do is we actually drastically reduce the resistance there, and that allows the motor to run on a lower voltage. So we have 8 here, so that means we want to look for 5. So here we go, clamped onto 5, clamped onto 8, everything's clear. Do our test. There we go, great insulation. So moving along here. Six and 3. So there you go. I just did that on purpose so you could see. That's going to read a short, and that is because 6 and 3 is a coil. So that's going to read as a short, and that's perfectly normal. It's what you should see. Just as if we did any of these others. So what we got here is a good motor. You do have to watch with these also. Not everything is meant for the voltages that you put on it. This particular one doesn't have super high voltage in it. If we were going to run this at 480, I probably would have tested it at 1000 volts, but this is going to be part of a Frankenstein project here in the shop. We're going to run it at 240 volt, single phase. Yeah, so a little bit more research getting done on this project, but it should be a fun little project. But now that everything's tested out, what we can do, you can see here on the nameplate of the motor, we splice 4, 5, and 6 together. So what that looks like is 4, 5, and 6. All these here, we'll splice those together. Basically what we're doing is we're paralleling these together. So see how coming from factory 7, 8, and 9 are put together. Well, we're putting 4, 5, and 6 together. We created the same thing here, and now we're going to run these two fields in parallel, which is going to take care of our voltage issue for us. So now 1 and 7 will go together to L1, and then 2 and 8 will go together to L2, and 3 and 9 will go together to L3. When we look at this, I know it's a squiggly mess, but we're actually taking two sets of windings and putting them in parallel with each other. And what that does is reduce the resistance in here, which allows a lower voltage. So that allows us to run the motor at a low voltage. If we were to connect 4 to 7 here, 5 to 8, 6 to 9, we'd be increasing the resistance in here, because we'd still be hooking 1, 2, and 3 for our line 1 and 2. We increase the resistance in here, which would require a higher voltage. So that's the difference here. One hookup would be series, the other hookup is parallel. That's the only difference. So 3 goes with 9. And I think what we'll do, I will temporarily wire nut these together with these wire nuts. Maybe what I'll do is I'll get out some set screw wire nuts and show you guys how those actually work. 3 goes to 9, just like that. Try and get some of this twist out of all these. Play around with these motor leads, you get yourself a knot. So these 3 will go together. And actually, let me do that quick. I'll go get a set screw wire nut and we'll put that on there. I showed what they are in a previous video, but I didn't show installing them, so hopefully we can do that here. Give me a second. Okay, so we're back. So set screw wire nuts, we went over them briefly in another video. You have a holder here. You have this this piece. There we go. And this piece will go in your holder like that. And you take the wires, these wires like here. Make sure they're put together nicely. And you put them into here. And then we tighten it. Trying to do this in frame. You don't have to kill them, but you want them snug. So there we go. So what's the advantage to this connection? It's a good mechanical set screw. It's good in high vibration areas, which motors obviously vibrate. And here you go, this is your cap, goes right on. So that's our connection of 4, 5, and 6. So this here, I'm just going to temporarily wire nut the other ones because of the fact that I'm not going to finish wire this right now, but this one we could. I'm going to end up taking this apart again. So 2 and 8 go together. That's these two. Should have probably yeah, well. And 7 and 1 go together. That's these two. So now when I bring my power feed in here, I'm going to be tying into these. This connection is already done. We can stuff that back up into the motor here. This motor's a good motor, good to go for our experiment coming up. There's our ground connect. No, you can't see any of that, but there we go. We got everything in, and we're ready to go for our experiment coming up here. So tested the motor, good motor. Just playing around in the shop here. Got a new tool. Thought we'd test it out. Works great. Pretty happy with it so far. I haven't done a lot with it, but play around with a bunch of stuff like this, so it's nice to have this, and we're going to be getting some good use out of this in the shop here, and possibly taking it to work every now and then. We'll see. Sometimes it's just handy having one of these for troubleshooting, and got a pretty good deal on it. I did get the added magnetic clip for it. I'm a big fan of these magnets. It has some sort of standy dealio here, but I'm not really keen on those sorts of things. I'd rather, you know, magnet it onto something there and do it. The leads, I gotta say, on this meter are pretty nice. They are pretty nice and pliable. They're not fluke leads by any stretch, but they're nice. It did come with 2 other leads here, your probes for getting into other areas. They're nice length. So there we go. Came with them. These pull off, but in the context of this thing, you want to have as little exposed metal as possible. I cannot stress enough that this is a very dangerous tool if you do not know how to use it. So don't willy-nilly buy something like this and think you're going to play around with things. You can damage things. You can hurt yourself. Be very careful with these things. So there we go. Tested out a new tool. Pretty happy with it so far. Haven't done a lot with it, but I thought I'd share. If there's other electricians out there or maintenance guys looking into it, if you don't need the super high voltage, so far I'm happy with this. I mean, you can see me using it. I think I found that one quirk there on the test. You gotta not just peck the button. You gotta make sure you hold it long enough. I just not used to. I've never used one of these before, so I've used the old. And maybe sometime, if there's interest, I'll show it. I've used the old hand crank style, and I also have an older Simpson that has a push button, but it has a little. It's hard to explain how it works, but it's more analog, and it's much more obvious that it's putting power out. So, and I don't know, maybe we'll find something and check the resistance across the different meters and see how accurate they are with each other. So there we go, little video there. Again, be careful with these. not a toy, not something to play around with. People can get hurt, and you can do damage to property and what have you. So I am not a representative of the ins and outs of the workings of these. I'm just a guy that went through and checked the motor. That's one of these things. I'm not an authority on anything. I'm just trying to share some of what I learned over the years. Maybe some of what I did here is could be done better or different, what have you. But that's, everybody does things their own way. That's why we have a conversation about the stuff. So either way, new toy in the shop here, and getting ready for another project here. Hopefully we'll have some content on the channel with that. And thanks for watching. Have a nice day.